This is maybe even a little premature. Do you have a? Can you go back? There was a drawing or a picture, like a slide. Wasn't in the PDFs. It was in.
Sure.
Yeah. It was in your presentation. There we go. Can you make that bigger? Can you zoom in on these? Hey, nice. Okay. So let's go. This is a touchscreen, isn't it?
No.
Oh, okay. I thought I. All right. Let's start here. Just go down just a little bit. So that's the trailer outside. Are you recording? Excellent. That means I want to watch my mouth. So we have an issue, known issue, always have. When you attach steel to wood, you get sweating, condensation. Steel's temperature changes swing pretty dramatically compared to wood. So steel gets moisture either on the inside of the tube or the outside of the tube. And we have a lot of tubes in this big giant moment frame. For those of you who might be in engineering classes as well, the whole thing is a giant moment fulcrum frame to keep torsion and racking out of the chassis and out of the structure that we posted on the corners and over the sill plate, right? So we need to seal this up or break that moisture bridge somehow. And you guys already have your spray foam insulation filled in there. We shingle the sheeting on the bottom, the flashing, so that water sheds when it's under tow. Once you fill it up with closed cell spray foam, it kind of hermetically seals everything up anyway. The reason that we don't weld or make a continuous sheet under the bottom is because, well, if you've never tried to put a piece of sheet metal on upside down over your head, you'll understand why that's not a big giant 20-foot sheet if you ever need to get into the floor to do any repairs on the home. So we had you in mind, or at least the homeowner, when we thought that through somewhat. So once the spray foam's in, we've kind of sealed up all of the nooks and crannies in the bottom of the floor so critters and stuff can't make it into the structure. And then we're going to take across the top here this pink foam tape. It's not even really tape, it's just thick polyiso foam called Sill Seal. There are numbers of substrates out there that you could use as a gasket or moisture barrier material. Sill Seal's really, really cheap. It's readily available at any Home Depot, Lowe's, Ace Hardware, blah, blah, blah. And we use a couple dollar can of spray adhesive all over the top of the trailer where we're going to put that pink foam tape down. It's right there. And that includes underneath. So here's our sill plate, right? Running underneath the flash or underneath the subfloor sheathing, and that's Sill Seal. So it's got about an 1/8 inch of squish to give you a nice foam gasket between the wood and the steel, so that the steel, if it sweats outside of the tube for any reason, it won't soak right into the subfloor and cause rotting or mold or any nasty stuff. Okay? Any questions about this? All right. So this is our Advantech, not our Advantech, but this is the Advantech product from Huber Wood Products. It's like OSB on super steroids. There's probably as much Gorilla Glue in that sheet of OSB as there is wood chips. It's really heavy, really dense. It's got a 3-year exposure rating on it, and you know you're not going to get that out of OSB or MDF even. So a couple of drops of water and that stuff starts to delaminate pretty quickly. We regularly have this stuff sit out in the yard for weeks to months with snow and water and rain and UV, waiting on customers to come pick their projects up, and we see no deterioration. The only thing that we will caution is that if it's going to be fairly wet before you get the roof stood, once you get your subfloor down, it's a great idea to tarp that, because on the reveals every 4 feet, you'll get some seepage through the tongue and groove. And that if it's snow, for example, all that seeps right down in and it's laying right on top of your spray foam under your subfloor now. So don't do that. Once you got it all down, cover it up. Any questions on this yet? We're going to talk about the screw schedule next.
So we're leaving a 1/4 inch gap between the fender and our Advantech.
That's okay.
Oh, no, that was the question.
Oh, you're leaving a 1/4 inch here?
Yes.
Perfect. You'll have some.
We saw that in one of your videos. tough.
Yeah, it's to clear the welds and allow for expansion and contraction here. The reason we put so many screws in the floor is because it is a steel subfloor. Okay, they're not wooden floor joists. The steel doesn't want to expand and contract underneath the wood that does. So we've got to hold it in place really, really hard. So we do a 12 by 16 screw schedule. Can you guys see the lines here? Going back and forth. We come in about, the first line's 7 inches in. If you've got an 8-foot wide chassis, that means it's 1 inch in from the fender, and that splits the tube lengthwise down the main frame of the foundation itself. So on either end, snap that chalk line at 1 inch, and you know that's where you've got 3/16 or 1/4 inch steel to bite with floor screws. Okay, and you do the same thing on 16-inch on centers for the cross members, and alternate your reveals. So we don't screw out here necessarily because we're going to put the silver on the bottom plate of the wall there, and the whole structure ought to be enough to keep that edge from wanting to come up. And we're going to bolt through those. Any questions on layout yet? There's a little drawing that Kristen sent. There's our screw schedule. So you guys can see 16s going this way, and we come in 7 from both edges of the trailer, snap a line, and come out from each side and go in 12, 24, 36, 48, 60, 72. I don't care which way you do that as long as you get the 12s by 16s. And right here where you have your reveals, that's your seams or your joints of your sheathing on the floor. Alternate the screws.
By reveals, they're still tight.
They're tight. Yeah, I believe, I think they say an 1/8 inch on the T&G. So a nickel is a good shim to put down on either side of a sheet and then tap it with a rubber mallet. And that sets your tongue for the right depth for the groove and it won't want to buckle up on the reveals there, okay? Alternate your screws, left and right of the tongue and groove, because you got 2 inches to land on, but you got 2 big 1/4 inch bolts that you're going to screw in. So we say do that to kind of pull those together. And if you do one on either side, you're going to run into the likelihood of hitting the bolts underneath the steel
So
tube.
yeah, Brent, this was your question this morning about at the seams. How are we connecting at the seams?
Straight up and down, come in about 10 or 15 degrees and go in through, get as close to the seam as you can, but still have enough meat on the back side of the sheet that you're going to screw through, and go from 90 down to maybe 75, and then shoot it in, and then move 6 or 8 inches to the adjacent sheet and do the same thing opposite. So it's left, right, left, right, left.
Not
Okay?
necessarily following the 12.
Yeah, you're still going to do it here, but you really only need to do it like either or. And if you feel like it's a little floppy, an extra couple of screws is just free elbow grease that you're donating. It's not going to hurt anything, so feel free. Any questions here? I think we covered that pretty well.
So the sequence is going to be snapping the chalk lines, getting all its dimensions right, and then
You're going to snap this pink grid on top of the floor, okay? So snapping that grid will give you all of your intersect points where you're going to drop a hole and a screw. If you choose to use, I know that Simpson Strong Tie and a couple other companies have a self-drilling screw. We personally have one that's specific to the trailer and truck industry. But the one that I personally prefer is 2 guys, 1 drill, 1 screw gun, pilot hole, chase, pilot hole, chase. It's a little labor intensive, but myself and 1 other person with the other screw, we get in a rhythm and we can knock that out in about 40-45 minutes start to finish. That includes snapping the lines. So it's not really that hard. We don't have one here today that's got a subfloor installed yet, do we?
that's what I'm
That's first step?
Yeah, step
Okay.
one.
If we kind of cruise through, we can maybe get to that point.
We can yeah.
Do a
we
little
can-
bit of
we can
layout on a
finish
sheet or
stuff.
two so you guys can see that firsthand. So let's move through from here. You guys understand where the subfloor goes on, right? Okay. The next thing we're going to do after that would be to assemble the walls. You want to give a, yeah, if you want to run the AV department there. So wall assembly is kind of tedious. Let's start here, yeah. Okay, perfect. We've got a couple of different types of screws currently. So we have some that have a drill head on them, and we have some that do not, that just have a point. Let's scroll that up a little bit. Right there. Okay, headers. We got two different types of steel. We got C channel, which is called stud, and we've got U channel, which is called track. Okay, so we're gonna learn a little CFS nomenclature for a few minutes. CFS, being the intro to the nomenclature, cold formed steel. Okay, fancy way of saying gutter. That's about what it is. We're building houses out of seamless guttering. It's just a little heavier material. So this is a U channel, right? And this is a U channel. These are two C channels. We're facing those back to back. We're building a header here. Okay, this is kind of a critical nugget of data that you guys are going to want to know, because this tells you how this stuff all assembles. Because IKEA is really cool about giving you that funky tool, but you can't really build anything with it without the instructions, right? So we have to give you those instructions for our IKEA furniture too. So we've got a stud and a stud captured by a track and a track, and we effectively have an I-beam that's fully insulatable on both sides and is ready to receive either studs above it in a window placement, for example, or we can flip that around and orient this 180 degrees and receive the tops of the studs below it as well. So it's an integrated system that allows us to use very, very few parts and pieces. We don't have to know a whole lot. We just have to come up with a lot of ways that we can use what we do have, right? So that's how a header goes together. And we put, where you see arrows, put screws. So drillers, if you'll scroll down back to the top for me one more time. These are used to shoot through where there's no hole, okay? These are used to shoot where holes and dimples line up. And the only reason there's a point on that is to just kind of get the holes to self-align and then drop the screw through it. Okay, go back up for me. Next is a beam assembly. I don't think you guys have a beam in any of yours because you're both shed roofs.
Do you want to take a look at the 3D
Sure.
sketch of the file first? And then just identify when we're talking about headers. So we talked about this morning, but headers are everywhere we have the red.
Wherever we have to transfer a load around an opening, we've got to have a bridge to clear that span, right? So those spans go to their adjacent jack studs, where you see the orange, those are king studs or jack, structural columns, if you will, in the design to carry that header, and this header is carried by those two little ones there to clear and span fenders. So that burgundy and gold is what we just learned how to assemble, and these are just indicating how they transfer their load, and that's for us to be able to stamp and do finite element analysis and engineering stuff. So this is color coded a bit to help us know what those pieces do in the walls and in the roofs. It's kind of like a legend. Oh, if it's burgundy, that's an I-beam header. If it's yellow or gold, that's a structural member of the wall support.
Are the jack studs or king studs, are those different in any way, or are they just colored differently?
Just color differently. It's just to kind of discuss load and layout of the wall and why a little bit. And if you take this, so our software lets you go from TM Modeler. This is we designed it. We didn't design it, but we had it designed. The software that builds what you guys are building in the flesh now. That has a plugin that lets us drop into SketchUp or Rhino an SKP file, but then I can also backput it at some point. It's a little beta-ish. Rhino will let it come back into our framer and modeler, so we ought to be able to do more editing on the actual roll forming process through Revit, Inventor, Rhino, SolidWorks, anything that'll use DXF or a SketchUp file. And we're trying to make this almost a standalone plugin. Like it'll run itself, but it'll also run alongside of anything that's way more powerful than it is. Why do I need to reinvent SketchUp? Why do I need to invent Rhino? I don't have the resources or the interest in spending all the time to do something that they've already done. We just want to be able to use some of their code and some of their functionality in our stuff too, so that you guys can build and design cooler stuff in a much shorter A to B process.
So, yeah, I don't think we have any speed.
No, I didn't see any in there. All right, there is a good place. So these connectors, these are off-the-shelf Simpson Strong Tie connectors that we use in a lot of different configurations. All of these are kind of customizable, meaning you can bend them to fit. They have slots and grooves and little things. So for roof attachment, for uplift, you can do a clip here. This is for side attachment to when you've got wall corners that you want to attach. Use this. We've got some others as well. If you guys have, I think your box has all that we've established you'll need. But if there's any weird ones that we missed, we may just have to get on the phone with Simpson and say, do you have a better solution than what we found on your shelf last time? We work with Simpson Strong Tie here locally because they have three regional field engineers based out of Denver. So that's really, really great for us to call them and go, so I've been thinking, and then that means they all come running out like worker bees and start troubleshooting and doing calculus. So they've helped us develop 4 or 5 new clips already that we're kind of proprietizing as we speak. So it will be a Simpson Strong Tie clip specific to our designs and our engineering. And we're probably 30 to 60 days away from that, so it's not going to help you guys a whole lot. But that was to point out we have a lot of back support from other companies who have been much deeper into the water in this than we have, leaders in the industry. So 2 companies that we partner with collectively probably have 80 years of cold form steel and truss and engineering design under their belts. And that's 2 partners, Simpson Strong Tie and Keymark Industries. And you know, we're pretty happy with what the 3 of us collectively have been able to do so far. And truly, guys, we're still scratching the tip of the iceberg, so to speak. We haven't really dug into what cold form steel can do for the industry yet. We just know what it can do currently, and we've pushed that a little bit. And our constituents, our competition has as well. You know, there's some cool stuff being thrown our way as manufacturers and designers and builders. We don't want to say no. We want to find reasons to say yes, so that when it's done, we go, ta-da, we figured it out. So that's why we like to partner with these, so that these clips, you know, when the school says, hey, we got a challenge, and I go, I don't know how to fix it, I call Simpson, they go, here's your silver bullet to all your problems. It's a great relationship to have. So if we run into any challenges, I think help's only a phone call away. And maybe some new designs too, new solutions. What's next?
Since we have this photo up here,
Yeah.
and I know it's come up as a question, where the framing, assuming this is roof framing,
Uh-huh.
and here we have at the end of the roof framing, sitting on top of the header up there, and if we have an angled roof like the shed roof that we have, it's going to hang over, you know, a fraction of an inch, half an inch at the top. At the front side, we're also going to have a little bit of an inset, something like that.
Right.
Is that something where we simply, you know, we put a drip edge over it, we put a sheet
Over it. Yeah.
just kind of
It's
fill it in?
Basically we're talking about, you know, matching roof pitches to miter cuts on the end of beams and posts and panels. Well, we can't. They're all very 90 degrees, right? So we'll have a square edge kind of hanging off to one side, and then it's opposite adjacent square edge kind of inset on the other side on both top plates of the houses you guys are building, right? And his question was, how do we pretty that back up? And it's drip edges and sheeting. It's carpentry is what it is. There's a difference between rough-in and finishing carpentry, and this is kind of bridging that gap. So you have to be a little bit of a rough-in magician as well as a finished carpenter to get CFS, and this is known and inherent in the industry as we're switching, and we are, just so you guys know. America is the last industrialized nation still building primarily with wooden sticks. Everybody else is on to this because there's an infinite, endless supply of it, and really, this doesn't scrub any carbon dioxide out of our atmosphere when we chop it down. So we're getting a little smarter finally, and we're starting to make America a better place to build a home by leaving our forests standing more. That's my personal take on why I ended up in the steel industry, if anybody wants to know. And I like that it challenges you to not do it the same way everybody else does. So to find those solutions on how do I clean up the fitment on the outside of that, because it's going to be a little atypical. That's just the nature of the beast. Unless you have a square 90-degree roof line, you're going to have to do a little coping and figuring it out. All right, end walls and exterior or interior walls. So these, you can kind of see a zigzag pattern. This is to prevent your joints from hinging. And I say that in terms of engineering. It's not truly going to hinge like a door, but if you got one straight line of screws, that holds really strong only in one axis. If you zigzag that screw schedule, now you've got it kind of holding on two parallels, and it's not going to want to collapse on that hinge point, okay? So every 6 inches with number 12s, that's 5/16 screw. So 6 inches apart go lower left, upper right, lower left, upper right. And then on the number 14s, if you guys choose to use those, you can spread the screw schedule out on your corners to every 8 inches. And that's a 3/8 self-drilling screw, tech screw. The reason that we do that, the number 14's got a little bigger diameter, so a little more bite. Need a few less of them in every corner per the engineers. 5/16 is a smaller but easier screw to shoot, but you got to do it more times. So that's why we give you that option. You can do either or, okay? Any questions here? Oh, here's a perfect example. Can you guys see that? That's just a little cap head Phillips screw. There's a dimple around that, and in the stick behind it, that one's actually piercing through. So this vertical stick's going through that diagonal brace, and there's a dimple here with a pilot hole, and then there's another one on the adjacent vertical stick behind it. So it's male to female connection. You line those two up and they kind of click in place. You'll see daylight, drop your screw in there. So that's how involved the assembly process is. Any questions? Good.
What's the best tool for the wall? Using, like I said, it's just a compact or just a drill or?
I don't.
Use a compact drill.
You can use a compact drill. I like the 1/4-inch impact screw guns. They come in the 1-2 combos. You got a drill screwdriver combo. I like the screwdriver part better because audibly I can hit the inch-pounds of torque I want with about 3 clicks of my hammer on that impact. So zzz, brrr, and stop. That's your warning light. Don't keep pushing the trigger or you're going to spin the hole out and then it's done. So zzz, brrr, get about 3 to 4. If you're like, brrr, eventually somebody's going to come over and tap you on the shoulder and say, stop doing that. You should have stopped a long time ago. So about 3 or 4 little on the impacts, and that's kind of how we train our guys, so they don't spin out a bunch of holes by getting real heavy with the drills. Some of the drills, they don't have the, if you want to set the clutch for a screwdriver setting on the drill, cool. You got complete autonomy to do that, because it'll do the same thing as the impact gun will.
So he's talking about the numbered dial that you're working on this morning. So
yeah, I'll leave the tool time to the educated ones to share with the less educated ones to bring them up to speed, because I can spend another 2 hours talking about how to run tools if you want. That would be really boring. Here we go. It's a good place to pick up this. HTT anchors. These are a Simpson product. You can put them either side of the stud. I don't care. They do their job the same. You drill a 5/8 hole through the flange, and then actually come up from the bottom. So we use a mag drill or magnetic base drill. It looks like a mini drill press, weighs about 30 pounds. And we turn the thing upside down and turn on the electromagnet to boom onto the bottom of that steel. And then turn the drill on and use kind of an end mill. It's not really a twister. It's like it's called an annular cutter, but it's a flat drill bit that hogs a hole instead of a drill bit that kind of starts in the middle and works its way out. This thing actually cuts around my finger a circle around the diameter that we want to cut, and there's like a plug that's left over. So it's a one and done hole shooting method. And then a 5/8 grade 5 or better. I like grade 8s, but grade 5 is all that's required. 3.5 inch shoulder bolts can be too short on the threads. Shoulder bolt means half threads, half smooth on a bolt. If anybody cares to know what that is. So like the threads are on the top half, but not on the bottom half, just out of the bolt head itself. And if you take 5/16 or 3/8 plus 3/4 plus about 60 thousandths, and then you squish it, you might not get enough compression on your Simpson anchor to have your torque specs met. So fasteners are critical. It's not so much for you guys because we put all that in your box. We went shopping for you. But again, remember, we're using this for DIY purposes as well. So we want all the DIYers to know that they need threads down well below the Simpson tie to get the house to lash fast to the foundation sill. And then we use the same deck screws that we did on the floor with a fender washer in between those. Put these about every 4 feet as close as you can get to it. You won't get it exactly every 4 feet, so those of you who are OCD, you're really going to struggle with that. It's not going to be every 48 inches, and I'm saying that because I'm one of you. This one is a 7/32 pilot hole, and then a 1/4 inch by 20 deck screw, same as we put the subfloor down. The only difference is we put a fender washer over that countersunk head, and it kind of sucks down the sill plate, or the bottom plate of the wall rather, to the sill, kind of creating a bit of a countersink attachment. Here we do that, I try to do that on either side of the opening, every 16 inches, get one close to the stud, one close to the stud, go around the opposite sides and do it again. You know, some people prefer to have it in the middle because they feel like it's bowing up, and I say potatoes, potatoes. They're both getting screws through the bottom plate into the sill. That's good. How you do your layout, as long as you've got 2 in between each stud, I'm cool. Okay.
Do you then go back and just for safety, do you break off the end of the screw on the other side?
If you choose, yeah. That's getting into builder preference. It's not a safety issue, but a lot of people, so you got that screw, this screw right here sticking out the bottom of this sill plate, and that's going to be all the way around the perimeter of the house. I have a lot of builders that do go over there with a pair of pliers, vice grips, or a nail and knock them off. And you're going to have 4 or 5 threads in here, so you're going to pass engineering. It's not going to pull. And it's a 20. You got at least 5 threads in here, probably 6. 3 is all you need. So you can knock all those off if you want. That's all right. What's next? I heard there was another question, but yeah.
Framing, like the order of framing things.
Yeah.
Great question.
Any expertise you can give us.
Yeah.
To speed up
This.
our
All right.
process.
For the heads that were kind of getting a little
This will be
naughty,
life-changing.
you guys stand up and shake it off for a second.
Well,
This one's important. Order of operations is paramount here. Okay. And some of the other cold form steel manufacturers don't give you this. They don't want you to. I tend to have faith in smart people a little bit myself, so I'm going to let you guys try it. And if you get stuck, we're only a phone call away. All right. Start in the top left corner of every panel and work your way down and this way as you're going across. Does that make sense? So I'm going to take stick D. This is probably stick A. I'm going to put a screw in that corner right there. Okay? Then I'm going to go and grab BS, BM, and BY. Okay? And I'm going to put them all up here. And then I'm going to D is not gonna go through those sticks, these are tabs right here. I know that that's gonna go around the outside of that stick, so I'm gonna go screw, screw, done. But E, on the other hand, I have to slide it through all three of those short sticks to get it to connect up here. So I'm gonna do that by taking these three and sticking them all up here, and just putting E, your BS, BM, and BY all at once, and then I'll knock those down. T looks like it's the same. Now it might be a tab, it's probably a double tab. You guys will start to understand what I'm decoding by looking at this drawing within about 10 or 15 minutes of playing with the sticks that we've unbuckled. So BM kind of looks like it's got tabs on either end of it, but this hole right here, that's going to be solid in between. So BM's got a tab, then it's not cut, and then it's got a hole through it, and then it goes out here, it looks like it's got a really long tab to grab those two studs. So what I see everybody do at least once, most of you will still do this at least once, that's okay. They'll put B in, they'll put BS in, they'll put BM in, they'll put BY on, and then they'll put B on there, that's the bottom plate, right? And then they'll go, well, now I can't get E in there because it's got to go through these three sticks, and I had to feed it from bottom to top. So just be careful. It's not going to hurt anything. It'll irritate you. Trust me, it'll irritate you, because you won't find it until you're probably 2/3 of the way down here. And then you go, hey, wait, what's this piece? Oh, it's that piece that goes right here. So just pay attention. Slow is fast, organized is really fast. I say take whatever wall this is, let's call that's probably exterior wall 1, okay? Take all of the sticks and tracks and studs and separate them per wall, tracking all up high, all the labels facing the same way, the same direction. Pretty OCD, so my brothers and sisters in the OCD world love this part of it. And then studs over here. You can kind of turn them where they're like this in front of you. This is what we've kind of discovered to be the fastest way from step 1 to step last. I'm not telling everybody you don't know how to be organized. It's just, this is a very specific order of operations thing. Put the top of your wall in front of you, and then step back, and then put the bottom wall piece in front of you, and then kind of start visualizing what goes in the middle of it, right? And if you see a hole through a little stick, like BM, BO, BR looks like it's got some pierce cuts, BX does. Don't fall victim to those and get all these vertical ones in first, and then come back and find out you now have to undo all that work to put those back in the first. See where I'm going with that? It's still going to happen. I still do it to this day when I help customers in our shop or when I travel. I still just remember slow is fast, and try not to create unnecessary steps for yourself. Yo.